Hello, and thank you for joining us for this public sector breakout session. My name is Christine Hand, and I will be your host today. We have some great speakers coming up during the next 60 minutes. Now let's get started. I would like to introduce Craig Marble with Astadia and Scott Spiro with Microsoft to talk to you about Astadia's U.S. Air Force mainframe to Azure project, leveraging Micro Focus. Craig, Scott, take it away.
Great. Thanks very much, and thanks everybody for joining us here today. We appreciate your time, and we think that you'll get some interesting information out of this session. As mentioned, we are here to discuss the United States Air Force project that we're working on. It's the IMDS mainframe replatform, and we're just going to give you an overview of what that project consists of, why they're doing it, and where its the target platform. So first, a little bit about Astadia and myself. My name is Craig Marble. I'm Vice President of Legacy Modernization at Astadia. Astadia is a Boston-based company, and we are a leader in mainframe modernization. We have three basic service lines: mainframe modernization and DevOps, and we also have a managed services business line. We do have a global footprint, and we've been in this business for 27 years with more than 200 mainframe projects under our belt. We do work with both IBM and Unisys mainframes. This particular review is on a Unisys project, but we do work with both IBM and Unisys, and we've got a 97% success rate, and we are a venture capital-backed company from Spring Lake Equity Partners. We also have a good relationship with Microsoft, have had for quite some time. What you see here is our CEO, Scott Silk, and Bob Ellsworth, the Worldwide Director of Mainframe Transformation at Microsoft, and Bob is presenting to our CEO. Our CEO is on the right. A 2018 award that we received from Microsoft as the top performer from mainframe to Azure modernization. So we were very pleased to receive that and work well and closely with Microsoft. And I think you'll find that out as I hand it over to Scott.
Craig, thank you. So my name is Scott Spiro. I'm the Global Alliance Manager for Microsoft, and I oversee our mainframe and mid-range to Azure partner ecosystem. We've worked with Astadia for many years, been involved in numerous migrations with them and Micro Focus. They've been one of our top performing partners for many years. So we've developed a great relationship with them and a lot of trust in their work, both here in the States and in the public sector market, the commercial market, as well as their international customers. So moving forward, in terms of being able to support the mainframe workloads in the clouds, we have the ability to support this. We've now grown our Azure data centers and our Azure footprint such that we now support 58 regions worldwide. And it's really the largest footprint of any cloud provider, at least twice that of our nearest competitor. And we're constantly releasing new and opening new data centers worldwide. With respect to the amount of fiber that we've laid, we have probably, I think they've calculated 3 times to the moon and back in terms of the interconnects. In terms of security and compliance, we have the most certifications and attestations, both across industry as well as geo, both on the commercial as well as the public sector side. It's really our aggressive compliance strategy that helps our customers address their objectives and meet the industry standards and regulations. We look to the compliance framework to including both the test and audit phases. We include security analytics, risk management best practices, as well as security benchmark analysis to achieve the certificates and attestations. And all of this information is available on Azure.com. In terms of the migration itself, so I've been involved in moving workloads off the mainframe, first to on-prem and now to Azure, for about the past 20 years. And so being able to support this on-prem in a customer's data center in an x86 environment, that's fairly standard these days. We've been doing that for many, many years. But now with Azure, with the fact of supporting both the public cloud as well as the commercial cloud, gov cloud rather, we have the ability to cross that barrier and support a hybrid environment. So with customers that are looking to move their workloads from the mainframe to the cloud, we support both an IaaS, infrastructure as a service model, as well as a PaaS offering. And we have the ability to work with you, and we work with Astadia and Micro Focus to make that happen. In terms of what we've seen over the years, I would say probably 85% of the Fortune 500 companies are using Azure. And more and more every day are taking their crown jewels, the core business functions, and moving that to the cloud. So very active and only increasing in terms of momentum. In terms of Microsoft, we probably have the most mainframe knowledgeable resources, which in the past people would think, wait, Microsoft and mainframe, those two don't go together. Well, we've built teams around the world, both at the field level, the sales level, engineering, marketing, and we have about 85 people worldwide that we consider mainframe champions. They come from customers. They've been DBAs, developers, system programmers. They've worked for the migration partners. So they have a lot of experience around this. So we have a lot of resources to draw upon internally at Microsoft to help our customers make that transition in their journey to the cloud. And because of this, we also are able to then incorporate a lot of the features and functionalities that you find in the cloud, or rather in the mainframe, in the cloud. So we want to make sure that both, now this highlights just the IBM side, but we have a corresponding capability matrix in terms of being able to support the Unisys environment as well. So these are some of the differentiators that we have, making sure that what you're running today in the mainframe has that exact same capability and performance in the cloud. And at this point, I'll turn this back over to Craig. If there are any questions, please feel free to ask.
Great. Appreciate it, Scott. Yeah, so Scott mentioned we're here today to talk about a ongoing project with the U.S. Air Force, and specifically we're talking about a system called IMDS, and it basically is their global maintenance and logistics system. It does run today on a Unisys 2200 mainframe, and we are moving that application and replatforming it to the Azure Government Cloud One, which is a special DoD area in the cloud that, of course, is very secure and has a lot of stringent rules around it, which I'll get into in a little bit. Before I go any further, I want to talk a little bit about what the drivers are for this project. So, of course, cost is a big driver, right? Getting from a very expensive, dwindling platform to something that's more flexible, more cost-effective, that's always a driver. In addition to that, you've got possibly a problem with finding COBOL developers, but not even just the developers themselves and people who know how to use COBOL, because COBOL is a language, just about anybody can learn COBOL, but really it's also about the systems administration. They're pretty specialized skills for those types of platforms. So one of the other catalysts, aside from all that, is being smarter and more effective and more efficient when it comes to maintenance and logistics. So if you think about it, if you think of it this way, these gears that you're looking at, there are multiple ways to approach an issue, whether it's a broken part or a broken down aircraft, is to be reactive, right? Something breaks, we got to fix it. So you might say, okay, to avoid that, let's do some periodic scheduled maintenance, which is good, but maybe you're replacing parts that still have life left in them, and that's really kind of wasting, right? Because maybe you've got another year left on that part, but just to be on the safe side, and as part of the scheduled maintenance, you're going to replace that part. So you could do something that's like proactive, and you figure out which parts tend to fail more, and develop a schedule to say, okay, I know that this part usually fails quicker than these other parts, so I'm going to pay attention to those specific parts and maybe take proactive steps to ensure that I don't have any delays in missions and things like that. But what you really want to get to is using artificial intelligence and machine learning to predict those failures, because you may have some aircraft that are in, let's say, the Arctic, right? And the parts and features of that aircraft suffer different wear and tear than something that may be in the tropics, which is a hot, humid environment. So in this system, when you track, we're replacing these parts, and this is why, and this is when, that's valuable information that through analysis you could say, hey, and combine that with sensors, right? Data that comes from sensors on the parts themselves to say, we know from analysis and experience that this part is going to fail on this aircraft on this date. So it really helps streamline not just the process of fixing those parts, but also the supply chain. So it really has an impact all the way down the chain. So just talk about the project itself. So the IMDS application is a critical component of the Air Force. It essentially, if it flies, this application manages it. So we're talking about fighter aircraft, we're talking about missiles, we're talking about drones, we're talking about cargo carriers, and you can see here that they have quite a few users, approximately 260 to 300,000 users daily, and touches other parts of the DoD and interfaces to many, many different systems like F-22s and F-15s, et cetera. So you can imagine just the inventory for all of those different types of aircraft. They each have their own inventory and parts list. This is a critical component of the Air Force IT department. So it's, again, not just the aircraft, but supply chain, right? So I need to be able to order supplies so I get them in time to actually use them. I need to order munitions so I can get them in time for any type of mission. I may want to record how long it took me to replace the tire of this particular aircraft and at what cost, so that I can predict what my costs are going to be and the time that it's going to take to do these types of changes in the future. The problem is this data is locked in an environment that is not necessarily easy to get to, and I'll explain more of that in a second. So a lot of it you have to pull that information out where we want to get to a point where it is you're able to get to that information in real time, and you can just kind of push that information out, pull it whenever you need to. So, excuse me. Again, some of the challenges that we faced, so that the Air Force faced. So it runs today on a Unisys Dorado mainframe. Unisys has a fairly small market share compared to IBM. The system has 3.1 million lines of code and upward. Luckily, it is primarily COBOL code, so that did make things a bit easier. And it provides wartime readiness data and weapon systems to our warfighters. So this is a critical application. If it's not running 24/7, it's a problem. So the Air Force took a look at some of their options, right? Obviously, one of the things they would look at is a off-the-shelf option, right? Is there anything out there existing today that we could use to replicate this functionality? Well, you're talking about a 30-year-old application that has a lot of very specific functions, and it's just not easy to find anything off the shelf that replicates that. You can also take a look at refactoring. So refactoring is in many cases a viable option, but and refactoring has gotten better. But you're talking about Unisys, and a lot of the refactoring tools out there focus on IBM COBOL and IBM languages, not Unisys languages. Plus, given the complexity of this application, it just seemed like a high-risk approach. So what they decided was to take a replatforming approach, and that is to take the application, keep it in COBOL, and but put it in an environment where it can run under a modern .NET framework, which we can do because of the Micro Focus toolset. So out of that, you're going to get 100% native cloud application with maintainable code. Your developers who maintained it today are going to be able to maintain it tomorrow. You've got a more productive development environment using Visual Studio and Visual COBOL within Visual Studio. And then they moved from their two Unisys databases, one called DMS, which is a network database, which is completely different from a hierarchical or a relational database, and a relational database called RDMS, and all of that was to go to Azure SQL. So, oops, excuse me, just lost my place here. So what I want to do now is just talk about how we're doing this. We aren't completed yet, but we are on schedule to go live this summer, and it's in actually in user acceptance testing now, and we don't anticipate any problems. So let's talk a little bit about how we are doing this project, and of course how we do all of our projects. So as mentioned, this is a Unisys Dorado mainframe. What you see here is just a typical architecture. Actually, this architecture is really very much the same, whether it's the Dorado, whether it's the Libra line, or even if it's IBM. It's pretty much, you're going to see a lot of the same things. For those of you who might know, Sperry is a company that combined with Burroughs back in the day to become Unisys. So the Dorado line came from the Sperry side of the house. And what you see here is pretty typical, right? You've got your primary operating system, the OS 2200, and sitting on top of that is your application, your batch. For Sperry, your transaction monitor, your online transactions are going to be handled by something called TIP. And then, of course, you've got the code, right? You got COBOL code. You may have some MASM code. Maybe you have some mapper. And then for jobs, you're going to use ECL, which would be similar to JCL in the IBM world. You also have your sequential data files. These are just flat files. And then the two databases that I talked about. And, of course, supporting all of this, you've got things like code versioning, security, printing, scheduling, and so on. So pretty typical stuff. And accessing that today, you do that through interfaces. Now, those could be custom user interfaces, meaning you're using a terminal emulator and you've got some GUI on top of it, which they do have. You could be using just your plain terminal emulator, what you might call green screens, right? That's the typical name for terminal emulation screens. Or maybe it's just coming in through the web as a non-screen transaction, but just something that's using COM area or some type of protocol to access data, send data, retrieve data. So what we need to do is replatform all of that into the Microsoft Azure Cloud One environment. And this is the reference architecture that we use. Now, keep in mind, this is Unisys. We do have the same thing for IBM. If you're interested in that, you can find it on our website. But you'll see at the top the graphic that I just showed you, which is the current state. And below is the Microsoft Azure environment. And you'll see they look remarkably similar. So we take always, with these types of projects, a least change, least risk approach. And so you see kind of at the heart of that is something we call the mainframe cloud framework. And you can see it looks a lot like what you see up above. You've got your batch application, you've got COBOL running, excuse me, on the base under the Micro Focus COBOL server. And then if you notice, instead of TIP, we have something called OpenMCS. And that is Astadia's product that emulates the Unisys transaction monitors, both TIP and COMS. So it sits on top of the Micro Focus COBOL server. We bring down the data files pretty much as is. Of course, we're converting from EBCD to ASCII. And then the really interesting part here is that we took the relational database, moved over fairly easily. Relational databases tend to be pretty easy to move. There are some differences, but not major. The real problem child here was DMS, because as mentioned, DMS is a network database. And through our experience and analysis, we know that if we were to go into the programs and change all of the DMS code to SQL code, there's so much that the DMS engine does behind the scenes that the programs would become unmaintainable. It would explode the size, 2 to 4 times. So we had to come up with a solution for that. So we have in our kit bag something called OpenDMS. And OpenDMS essentially intercepts the calls from the legacy programs, and the legacy program says, okay, I'm going to make this call to DMS. Here's the key and the information that I'm requesting. We intercept that, and in real time build the SQL statement that's required, interrogate the Azure SQL database. That result comes back, we reformat it, and send it back to the calling program. And that represents a critical part of the solution simply because it does make the coding much, much more maintainable. But everything else works the same. You got the same UI, the same sort of terminal emulator access, and the same web access you had before. So we take a least risk, least change approach. And then in the Azure environment itself, you have things like automated load balancing, right? So if your application is conducive to running in multiple VMs that you need to balance in order to meet demand and workload increase, well, the automated load balancer, it's a no-brainer. You just say, hey, if I reach this point, spin up another version of this application in another VM and start assigning work to it. So that part is really very easy to do. And we have the same sort of supporting pieces that we had before. Security through Azure AD, reporting, scheduling, printing, et cetera, version control. So all of these things are provided as a service in the Microsoft Azure environment, which means that you can actually get rid of a lot of third-party software by exploiting those services. So that, in a nutshell, is, obviously at a high level, is how we move from one environment to the next. Now, next I want to talk about process. So this is a process that we have honed over the past 27 years, and it works pretty well for us. What you'll see, I want to explain these arrows here. You'll see on the left-hand side there's 6 discrete steps, and some of those steps have arrows back into, you'll see, the transformation engine. So the way we do these projects and can do them efficiently is making the changes that you do have to make automated, right? So rather than doing hand code changes, which is error-prone and time-consuming, you always try to automate as much as you can. So in each of these phases, we'll find things that say, oh, you know what? We're having a problem with how we're sorting. I found the issue. So that rule goes back into the transformation engine, and then you can run the affected programs through the transformation again versus making those changes by hand. But we start with a discovery, and I can't emphasize enough how important discovery is. If you don't have good discovery, you're going to have problems later on. But we discover everything, the code, the data, the ancillary software, third-party software that's being used. But not just the software, but also the processes. How do you do your development today? How many times do you do releases? All of that information is collected in our discovery and all of the requirements that we need to meet in the project. Then we move into the design phase, which is where we start to architect the solution. And that includes not only how we might set up the execution environment, meaning the VMs and things like that, but also the databases, right? Designing the databases if you're going from a hierarchical database, or in this case, a network database to a relational database. That design work has to take place. You also have to figure out how many interfaces you have and how you're going to interface to those in the future, in the end state. And then, of course, there will be always some pieces that don't have a good counterpart on the distributed side. So there's always some sort of customization that has to happen. So all of that is done in the design phase. And then we start moving into the modernize phase, which is where the actual heavy lifting comes into place. And in reality, these phases will overlap, right? So you might say, hey, we know we're still in the design phase, but let's go ahead and run the code through the transformation engine and see what we get, because that can give us information that helps us with our design. So these don't have to necessarily go sequentially. But in the modernize phase, this is where we're making whatever changes we need to make to the code. We also try to find what data is static versus what data is dynamic and changes daily or by the minute. And the reason for that is static, when we're doing our cutover, it's nice to keep the cutover window as small as possible. So if there are static data that you can move over beforehand, then you don't have to worry about it during cutover. You can just move it over, leave it out there, and then it's there already when you're doing your cutover. And then, of course, we have to work on all the various application components like job control, things like that. Then, of course, we move into a testing phase. The good news here is that because you're reusing the vast majority of your existing code, and we know from experience that that code will work in the new environment, you don't have to test every single line of code like you do if you're developing new code, right? If you're developing from scratch, you really need to exercise every line of code to make sure that it behaves as expected. So the testing effort is very important and actually can be as much of an effort, in some cases a larger effort, than the transformation itself. But being able to test the areas of change and focus on those areas of change, where the data access components are, where the sorting components are, because you're sorting in ASCII instead of EBCDIC. So you really just focus primarily on the areas of change. And then, of course, you always run into a challenge if there are no test scripts available today. And we run into that quite often, so that's another consideration. And then once you get through the testing phase and you get through user acceptance, then you're going to do your cutover. So as mentioned, you get your environments set up and move your static data over, and then you start deploying all of the application components, the data, the dynamic data, the code itself onto the servers, do some smoke testing, some confidence testing, and then you're really ready to go live. And assuming all goes well, after you go live and the application is stabilized, then you move into the manage phase, which is where you say, all right, now it's time to manage this application and maintain it going forward. So that, in a nutshell, is the process that we use for our project and in this project. So because this is an incredibly important application, it must be available pretty much all the time. So Azure actually makes this very easy. So we have a primary region, and this is the primary region in which the application is running. And you can see in there that that's the one in the middle. If you have, again, multiple VMs that are balancing the workload, that's all controlled by the load balancer. And then, of course, you've got your Azure SQL database. But there is also a secondary region, and this is your disaster recovery or failover region. So these regions are up all the time. And on the left-hand side, you'll see the traffic manager. And that traffic manager is basically pinging these two regions constantly and saying, yep, are you there? Yep, I'm here, I'm good, I'm alive, and I'm working well. And if there is a problem, it automatically reroutes the traffic to the secondary region. All the while, behind the scenes, you'll see that little line there, there is active geo-replication, so that if you do have to fail over to your secondary region, your databases are in sync. So this is how we deploy high availability for this project. Now I want to talk just a few minutes about some of the basic software that we're using for this. Excuse me. So from Micro Focus, we are using Enterprise Analyzer, and I'm actually going to go into this in more detail because it is such an important piece of our project. Every project we work on, the first thing we do is put the code into Enterprise Analyzer. We are using Micro Focus Visual COBOL for Visual Studio, and that is the new development environment. And then we are using Micro Focus COBOL Server, which is the COBOL runtime companion to Visual COBOL. Then sitting on top of that, we have some Astadia software products. So we have something called OpenMCS. And OpenMCS is, for those of you who know Enterprise Server, is a lot like Enterprise Server in that it emulates the Unisys transaction monitors, both comms and TIP. It's a runtime that sits on top of the COBOL server and allows us to do the same thing that Enterprise Server does for Unisys. A companion to that is WebMCS, which is a web-based administration to administer your OpenMCS environment. Take a look at your MCS regions and make sure that they're healthy and manage them. And then, as I mentioned, a critical component of this is OpenDMS, which allows us to omit changes and insert SQL statements in the legacy programs, but leave them pretty much as is, and do that SQL conversion to Azure SQL on demand and in real time, and is one of the critical components of making this project a success. Because as I mentioned before, the changes would be massive without it. And then there's OpenTS, and this simply replaces the Unisys WebTS for 2200 systems. It's web access. So those are the primary tools that we use on this project. There are others, but these are the main ones. Now, did want to talk a little bit more about Enterprise Analyzer because this really is an important component of all of our projects, and in this project was extremely helpful in this project. It really helps you understand the application, right? So instead of doing manual research, you parse the code in, and Enterprise Analyzer supports Unisys COBOL. And it gives you all the relationships. It captures the relationships between programs and data files, between programs and databases, and it allows you to identify processes and helps you figure out how you're going to do this modernization project. One of the first things that you get is this nice little dashboard that gives you information, right? It tells you how many COBOL programs you have, how many job entities you have. In this case, it's JCL because this is a sample. Gives you an inventory report, how many COBOL programs you have, copybooks, etc. So it does a nice job of giving you just the base inventory. And it also will tell you, hey, I see references to 30 programs here, but I don't actually have those 30 programs. So then you know, hey, I got to go back to the client and get these 30 programs because they're sitting out there somewhere, but I didn't actually receive it. But one of the great features is the ability to visualize the application, and this is where it really helps us. So if you see here, this is a call map, and in this sample, you see what we call 3 hairballs or 3 star systems. So these 3 star systems let you understand, okay, the center of these star systems are obviously something that's important. It helps you also say, if I'm going to do a proof of concept, I'm going to try to carve out a piece of this large application. I can see smaller areas here that look rather self-contained. So I can use this to visually identify areas that might be good for proof of concepts or areas to focus on in your modernization process. And then, of course, you can zoom in, which is really nice. So you see down on the bottom right, you've got your large star system there, and that little blue square. Then you can zoom in and see in the main panel what you're looking at up close. And then to get down even further, you can say, all right, I want to click on that program name, and then the code will come up, right? So you can take a look at that code and get an idea of what you're working with. So again, it is very helpful for us in our planning, in our analysis. And again, here it takes, you see that really dense star system there on the bottom right. It just allows you to sort of take things a bit at a time. It makes it a lot easier to plan out your project. So one of the last things I wanted to talk about here was the Cloud One environment. So the Cloud One environment has a lot of strict regulations and rules associated with it. One, of course, being security. But there is, everything in the Cloud One environment has to be done through DevOps. So you can't just say, oh, I've got a new program, I'm going to go to my Explorer window and I'm going to drag and drop a new program into next test environment or my production environment. That is not going to happen in Cloud One. Everything has to be done through scripting. So as part of this project, we supported that by creating DevOps scripts, and it does everything from defining the servers through dynamic server configuration to promoting code, everything. And also a part of that in other projects, we use this to put in place testing as a service or automated testing, which is important because, again, a lot of times clients don't have test scripts. So if you have tools that you can capture workflow, it's very useful, right? So I can capture a business process and then replay it over and over again for testing. And we find that using DevOps and testing as a service as part of our projects not only simplifies and reduces the time that it takes to achieve production, but it also is added value to the end user, because now they have a fully enabled DevOps testing, automated testing service that they can use going forward after we hand them the keys and go away. So it's initially was designed to help us, and now it seems to be something that is valuable to end clients. So another big important component of this project and other projects. So finally, I just want to go through some of the benefits. So from going from the IMDS application to the Cloud One, this was the largest, or is the largest, most complex application that the Air Force had on a mainframe. And by taking it to the cloud, they really see it as a pathfinder. So pretty much from their perspective, if this can run in the cloud, then pretty much all their other mainframe applications can run in the cloud. So this is something that proves to them that this can be done and is a strategy for them going forward. There was, and will be, a significant cost reduction. It's estimated that they will save about $21.5 million a year once they go live, which is a huge, huge savings, and allows them to do what we call self-funding modernization. What I mean by that is that $21.5 million in savings can be redirected to other modernization efforts, such as getting to predictive analysis. Now they've got this data in Azure SQL, right? So they can work on exploiting that data as part of their machine learning and artificial intelligence initiatives to get them to not only just make it easier and faster and more efficient for them to do repairs, but it affects everything, supply chain, all of that. So it is a big benefit to them. Excuse me. This also drives an agile and a DevOps environment that supports the warfighter, which is very important, and really passes the baton to the next generation. So a lot of new recruits coming to the Air Force, they don't know COBOL, but they are working in an environment that is familiar to them, which is Azure, Visual Studio, and really sets them up to take over the maintenance of this application going forward and into the future. And with that, I think maybe we can open it up to questions.
Yes, thank you very much, Craig, and thank you, Scott, for a great presentation. Don't forget that you can still submit your questions using the question box below the slides. We have had some questions come in. So first question, how do you know my mainframe application can be moved?
I'll take that one. Quite honestly, I don't, and I'm being perfectly frank. Each mainframe application environment is different. So as an example, if you've got a mainframe and let's say that it is primarily assembler and maybe a little bit of COBOL, it may not be a replatforming effort. Maybe the COBOL can be replatformed, but you may find that assembler should be rewritten, right? So there are a lot of different combinations you have to consider. The more COBOL, the better. That doesn't mean that you can't handle things like PL1 or Fortran or other languages, but until you get in there and do a discovery, it's hard to know exactly what your return is going to be on that specific approach. So you really need to get the entire inventory, take a look at all of it, and say, okay, if I were to re-platform this is my cost, versus if I decided I want to do something like refactor part of it. So there really is no one-size-fits-all, but I would say a good 80% of what we see comes over. But if you have any questions about it, you really need to contact us so that we can take a look at what you're dealing with.
Great, thank you. The next question that has come in, how do you perform testing if there are no existing test scripts?
Yeah, this happens all the time. So, as I mentioned, one of the best ways of doing this is through capture tools, workflow capture tools. So there are a number of tools out there. Micro Focus has some, other vendors have some, that you can bring up your system in a terminal emulation, and if it is green screen or if it's a GUI screen, you bring it up in your GUI screen, and you essentially run through a business process and captures each stroke, each screen, and records the expected result. Then that can be replayed over and over again. And it's a lot easier than sitting down and writing out test scripts to say first click here, first click there. If you can do that in an automated way, it really streamlines the process, because then you get into a cadence where a developer says, okay, I'm going to check out this program. I'm going to make my change. All right, I've done it. I've compiled it. I've done a little unit test. I think it works. Now I'm going to check it in and then kick off that automated test process and then get an email at the end to say, yep, it passed, so I'm putting it into the next level and kicking off the next test. Or, no, it failed. Here's the output. So that's really how we handle that, is through capturing the workflows.
Great. Next question that came in, what are the primary reasons that agencies move from the mainframe to Azure?
Craig, I'll take this. So this is Scott. What we see most is the primary driver is really cost. As Craig mentioned before, the cost savings on the Air Force project, you're probably looking at about a 90% cost savings just for that project alone. On average, we see between 80 and probably 85%, but some are more, some are less. It really depends on the scope and the complexity. In terms of other drivers, the second one we would see is skills. It's a skills issue. It's becoming more and more difficult to find not just COBOL programmers. Comparatively speaking, those are easier to find than assembler programmers or system programmers on the mainframe environment. So skills issue is another factor. And the other factors we see also are agility in terms of being able to address your expanding environment. As organizations become more cloud first, in some cases they standardize on a single cloud. In other cases, they have a multi-cloud strategy. So it's the ability to interoperate and integrate with either other applications within one cloud or across multiple clouds. And then it's also, the last one is really time to market. So how fast can you deploy an application into Azure? And using Azure DevOps, using the tools that you have, using new tools, the time to market can be reduced, in some cases significantly.
Great. Another question that came in, does the migration allow the U.S. Air Force to use AI machine learning against the legacy data?
Absolutely. Absolutely. That is one of the drivers, is getting that data into what you might call a normal form, meaning in standard relational format, so that it is easily interrogated and part of your business intelligence and artificial intelligence, analyzing it, learning, and making predictions and analyzing it. Because if it's stuck in DMS in a siloed environment, it makes it much more difficult to do that, and possibly makes it impossible to do, depending on where it is.
Great, thanks. And Scott, I think you touched on this, but another question that came in, how long will this project take start to finish to be running live in Azure?
Let's see, this project, and Craig, please correct me if I'm wrong. I think the go live date is July of this year. This project, I think, started, was it back in 2018 or was it 2019?
Yeah, it turned out to be about a 2-year project. Yep, took about 2 years.
Again, the duration, the duration is really dependent upon the scope and the complexity of the mainframe environment. What other applications or systems upstream or downstream that have touch points.
Yep.
Great. Next question. What were the primary challenges you faced on the Air Force project?
So there are a lot of similarities to other projects, but given that this was a federal project, there were some quirks. One thing that comes to mind is red tape and documentation and forms. A lot of documentation required, and that's just the nature of the beast. So that was a challenge for us. One of the other things, and that not necessarily on this project, but in any project like this, it's a three-legged race, right? It's got to be a collaboration between you and the client, or us and the client. And any mainframe shop with developers who you're talking about their baby. They've been working there for in many cases a long time. Are understandably skeptical, right? And they may know that other companies have migrated or replatformed and say, yeah, well, we're different, and I don't see how ours could do that. And there was skepticism initially with this project because it had been attempted before. But I have to say that after we had some early successes, the team that we were working with at the Air Force have been just awesome to work with. Been working side by side with our consultants, developed some good relationships, some good friendships, and they've been great and been very supportive of us, which really has been one of the reasons why this has been a success. That doesn't always happen. You can have projects where up until cutover, people are trying everything they can to throw wrenches at it and derail it. So in all of these projects, the technology, I'm not saying that it's easy, right? It's not like a magic button, you press it and it's done. But the technology works, and there are solutions to problems from a technical perspective. And that part is, for lack of a better word, the easy part. It's the human factor that tends to be one of the biggest challenges. And then, of course, testing. Testing is a big part of any project. For these types of projects, it can be, even though you don't have to do as much testing, meaning you don't have to exercise every line of code, you still generally face an issue where all of the test scenarios are in somebody's head. So you have to extract that in a way that is efficient and works for the project. So those are the challenges.
Next question. What are the transactional performance comparisons between the two environments?
Mm-hmm. Yeah, so performance is always a question, always an issue, and our mantra is we perform as good or better than the mainframe. We are extremely close to the existing service levels and doing everything we can to get to that same service level. I think we're pretty close to that. So there are a number of ways that you can address that, and actually the cloud makes this a lot easier to work with than, let's say, an on-prem solution. What I mean by that is, if you say, hey, I'm not getting the performance that I need, I want to take my machine and I want to give it, another, I don't know, 12 gigs of RAM, and I want to give it a higher processor, a more powerful processor. It's so easy to do in Azure. You don't have to get order equipment, install it, and try it out. You just do a few clicks, and you can try out different things until you get the right combination. But when this is done, we are going to be at or very close to the current performance they have today.
Great. Question just came in.
Mm-hmm.
Were there interfaces with other mainframe and non-mainframe applications, and how did you handle that when the applications were migrated to the Azure environment?
Mm-hmm. Yep. So all interfaces, we handle them one by one, and as mentioned, we do a least change, least risk approach. So if somebody is interfacing to the mainframe today through something like a web service, then we handle it in the new environment the same way as a web service, which is one of the reasons we have OpenTS there. So really, the goal is to interface to your third party, whether it's a mainframe or some other distributed system, in the same way that it is done today without forcing the third party to make changes, only unless it's absolutely necessary. But that's the approach that we took.
Other question, didn't the U.S. Air Force attempt to convert this application before? Why did this attempt work?
You want me to answer that, Scott? You want to take it? Okay, I'll do it.
Go ahead, Craig.
Yeah, I do believe that there were initiatives in the past. I don't have a lot of insight into why they worked, but I think I have a pretty good idea. And again, it goes back to the least change, least risk approach. So this application, as I mentioned, is 30 years old. And over a 30-year period, they have accumulated business rules and processes, and to go through and try to dissect all of those business rules and processes, turn them into requirements for rewrite is it's a daunting task and very expensive. By the same token, using a code refactoring tool is a higher risk approach, especially for an application that is, for one, Unisys code, and number two, has such high complexity. So I don't have a lot of insight into the projects before, but again, I think the reason that this one worked is because we are using proven tools, the Micro Focus foundation of their COBOL compiler, so very little of the change in percentage-wise in the code itself. And anytime you make the least amount of change, you're going to increase your chances of success.
Great. Thank you, Craig. Thank you, Scott. I believe this is all the time we have for today's questions. I would like to thank our speakers and our audience for your participation and hope to see you in our upcoming sessions. Thank you all. This concludes our session for today.